Okay, so let's start. If somebody actually attended my last FLS, last FLS that I gave was on Dart and what actually Dart as a language is. And in that, I actually showed a small, very small preview of what Aqueduct is and what it is used for. So Dart is a language which actually is in the market right now, growing and giving a substitute for the backend developers to develop front end. It is a language that has been helping developer across the board to replace JS, because again, whoever the JS developer here is, they understand that JS is a very haphazard language, which in which creating structures and prototyping is very hard. And again, it's not a strongly typed language, so that creates a lot of error handling and a lot of problems while coding. And that is where Dart comes in. Dart is a strongly typed language and which in a lot of terms resembles Java, and that is why it is very easy for developers who are actually backend developers to understand and learn Dart. So it gives us an understanding of like, if we are a backend developer, then we cannot move on to create front ends. That it actually negates that particular point. So for each and every backend developer, if you learn Dart and how to write Dart, you can easily create front ends, because there are multiple frameworks now available which help you do that. One of the biggest one that in that is Flutter. Flutter right now is helping everybody using Dart to create web apps, to create iOS apps, and to create Android apps. So, but it's not just that Dart just writes front end. It also we can also write back end with Dart. The same way today, we cannot just write front ends with JS. We can write back ends using Node. So Dart gives a Aqueduct is the framework that is mostly equivalent to express.js. But although it is being used for 3 to 4 years, it is still maturing because the community of Dart is not that large. Although Dart itself is being backed by Google, so the whole language is given by Google to us, and the low level language and the support is awesome for Dart. But again, Aqueduct is written it's open source, so again there's a community backing it, and it is hard for Aqueduct to gain momentum, because obviously JS is a huge market when it comes to creating fast and fast applications, fast developing applications, like where turnaround time is very low. That is the main point where it comes to it has a drawback, but again, because its community is growing, so it has a quite nice future. Plus the turnaround time while developing Aqueduct web services is very low, because it literally takes like 5 minutes to create an application and run it. So moving on, so what is Aqueduct? So moving on to that point. So is my screen still shared?
Yes.
Yeah.
Yes, yes.
So it's an open source framework creating deployable RESTful web APIs on the server. It has a similar flavor to Express and Happy, and as I just said, and offering entry with comprehensive list of features. So again, Aqueduct is not cannot be actually said to be a framework for creating microservices, because microservices inherently don't mean that they are web services in a way. They can be standalone backend services who are doing some tasks, but Aqueduct is used to create web services and RESTful web APIs. Aqueduct is actually not exactly what we will say, that it is like a completely different way of doing stuff in Dart, because just like Spring is Spring, apart from when it comes to Spring, Spring does not exactly extend what Java has given as functionalities. It creates its own understanding of how to do stuff, right? In Aqueduct has extended the HTTP framework that already is being given by Dart. Dart has a very extensive HTTP framework already written, but all that it gives us a very low turnaround time when we are working with creating that particular application and writing the routes and everything. That is why it is very good and actually very easy to use this Aqueduct as a framework and give out a an application, a web API in a very short turnaround time. Next, why should we use Aqueduct? So again, if you're using simply Dart to create, which we can actually, we can simply write a single file and create web API through that single file in Dart. It is that easy. Just exactly, you can draw parallels between writing web APIs in express.js and Dart that way. But what it does not give us is the ability to actually optimize our working. So what Aqueduct does is it gives us multi-threaded system out of the box, which in term I'll explain it a bit further in the next slide. What it does, it creates a memory isolates. It will, for each of the instance that it creates, it will create all the resources and connected to that particular isolate, and those will be isolated from each other. In Java, like if we have database, we create pools of database in which each of the thread can go to the pool and pull out the object that they need from that pool. That is not done here. Each of the resources isolated into their own environment, and that is why the race conditions and synchronization problems are not something that we have to worry about when we are working with Aqueduct. Everything, when you create multi-thread system, all the isolates are done for you by the Aqueduct framework. You don't have to do it yourself. So if you look at it, requesting is simply the place where all the requests are accumulated, and those requests are then given out to the routers in order to process. But the application which spawns the requesting and the isolates, it knows and in round robin keeps on giving each of the requests to each of the isolate, so that the multi-thread system works very inherently. We don't have to think about it in any way with our own understanding. Aqueduct will do it for you. Like in Spring and other frameworks that we do, we have to keep in mind about multi-threading and internal objects that we are creating. We have to keep in mind, if we are trying to make the system multi-threaded, then we have to keep in mind about all the rules of multi-threading. Here multi-threading is inherent, and you just have to tell that, okay, spawn a new thread for this application. So instead of running 2 threads of this application, you have to run 3 threads, and now simultaneously we can process, instead of 2 we can process 3 requests. Why use Aqueduct? So one of the very nice things that we have in Aqueduct is actually chaining. So fluid routing means you can simply create a route, and that route can be processed in multiple different controllers, which will be chained to each other. So if you see here, what we have done is the route teams, which has a conditional operator ID in it. So that is linked to 2 different controllers. So what will happen here is that the first authorization will occur, and in the same chain, it will not return the response from the authorizer. It will give the request to team controller, and finally team controller process it, and it will be returned to the client. So here, if as we can see, HTTP client requesting, as I mentioned, requesting is somewhere all the requests are accumulated, and then request is sent to the router decide which controller will it go to. This is the normal understanding that we all understand. Okay, this is how it happens, and everywhere it is happening like this. But with the Aqueduct, we can chain the controllers and they keep on passing the message from one controller to another, and then finally at the end of the whole process we can return the response. So in this way, we the framework itself allows for us to chain different functionalities into a single process, which if we draw parallels to Java and other processes, we have to internally orchestrate all that behavior. We can it is not given us to us out of the box, or we have to use intercepts and other mechanisms. There is also one more thing, that it has statically typed ORMs and database migrations available at hand. You don't there are no dependencies required, like in Spring. Again, I'm going to draw a parallel that we have to use Hibernate and other dependencies in order for us to connect to databases on the ORM level. So here we the Aqueduct has created its own ORM, and it is integrated into the system, so you don't have to import anything else. Finally, OAuth implementation, again, it is part of the Aqueduct core framework, and you don't have to think about that how will I implement OAuth 2 here. And same way, each application, each route can be chained into the mechanism that we actually saw here. Like exactly this is what it is being done in the example that I have shown, that the request from the router is given to the authorizer, and authorizer goes to the auth server and sees whether this request is valid or not. And then if it is valid, then passes it to the auth controller. And same way, resource, if authorizer goes from this route, then authorizer goes to the auth service, and then HTTP controller sees it and returns the response. And finally, this is actually not, to be honest, for everybody who has been working with Spring and other things. These are quite trivial. Everybody has this, but again, in what we can say, express.js or any other language, these kind of request bindings are hard to come by, and they have provided them internally, so you can use them quite fairly easily here. Getting the path, body, and header, and all of this, these are inbuilt mechanisms that you can use. Okay, so moving on, let's do some practical. Just give me a second. Okay. Meeting will end in 10 minutes, so I'll hope that I'll finish it before that. Yeah, so let's share screen two. So for getting started, you don't have to do much. All you have to do is install Dart in your system, and that is it. One more thing that you have to do is you have to install the pub global activate the Aqueduct plugin for the Dart, and you will need to have pub installed in your system. I think I have already explained this what pub is more or less the parallel to Maven in this environment. So you have to activate the Aqueduct first, and then all you have to do to create a project which will create the whole boilerplate for you is simply you have to write Aqueduct create heroes. If we like the name of the project to be specific, like here I have tried second microservice. I'm just going to create right in front of you third microservice. And all it takes is just writing create, and you'll have all the boilerplate stuff created for you right in there. It takes a bit of time to create. Meanwhile, I'll show you how it looks after it has been created. So this is the structure that we have, and the major things that we have to see here are a couple of files. One is pubspec.yaml. This is the main file which actually defines everything that we are going to do. It is going to define the SDK version that we are going to use of Dart. It's going to define the Aqueduct version, and obviously any dependency that you want to try and use in this project. And config.yaml is the file that we are going to use to write all the configuration, like database configuration and any other configuration that we want to add, and that will go inside this file. Then we have there's one very good thing given to this Aqueduct framework, that the deployment of this framework to anywhere, even if doesn't matter what kind of CI you are using, is very easy, and almost all of the environments are covered there. So you don't have to worry about that if whether you can run this Aqueduct on some CI or not. So it by default it already gives you Travis configuration to be written here, and you can create your own configuration to deploy Aqueduct anywhere using Travis. It is by default given here. On the page of Aqueduct, you'll find that there is a whole deployment section which is very nicely documented, and you can see all the kind of deployment that can be done using Aqueduct. Moving on, so in this system, so again, these are you can see there are 4 different uh, directories here, and each one has different work here. So Dart tool is more or less equal to the node modules to whoever is working with JS, and main code tests are where we write our tests, and again library is the area where we actually write our main code. Channel.dart is the file which actually by default is used by Aqueduct to define all the routes. So here, as you can see, we can define, we have defined the route read in this file. So again, we all are, I think, developers, so we all understand that first we have to initialize, and there are a couple of steps that are being followed in the, or when anything is orchestrated. So anything that we have to actually invoke, or we have to like initialize, that can be done in prepare, and that will make the objects available for us to be used inside the main methods. This controller method is where we have defined our route, and we can keep on chaining these routes if we want. So what all, if we want, again, this is, I've opened this up because I wanted to show how chaining works. So all we have to do is remove this and then chain it. If I want, I can chain more routes, and this makes writing this whole system very easy. So, and it also gives us a lot of leeway when we are working, right? And what I could do is, So also again, there is one more thing that we can do. Again, if we want to link more controllers to it, just as we did with our system here there in the presentation, as we saw that we can move from one controller to another. All that controller is going to do is get the request and give the response, and the orchestrator of Aqueduct will define if, on the basis of whether the request has been passed, request needs to go from one to another, is whether this REST controller on the response has given okay or not. If it has given okay, then it will move on to the next one, and if it has given like any error, then it will all automatically reroute the give the response back to the client that some exception occurred. So all this is being handled by uh, Aqueduct for you. You don't have to do it anywhere. This can be controllers can be defined in multiple ways. One, you can define either a controller, resource controller like I have, or you can define an HTTP controller. All these are different ways of getting the same thing done, and they are very easy to learn. I'll give you a link to all the links are actually available at the end of the presentation. You can go through all the ways to do this. And uh, one more thing that I'm not actually explaining today because it's going to take a lot of time, that is the, okay, only 1 minute left. That is the ORM. So most probably, because ORM is a huge concept when it comes to Dart, so I'm going to take up a Dart ORM based FLS next time. If you have any questions, you can ask. Hello?
हेलो
Yeah.
सर, जैसे इसमें रीड कंट्रोलर में जो मतलब सॉरी जो आपने वो राउटर जो बनाया है, तो सर उसमें लाइक उसमें हमें मेथड वगैरह डिफाइन नहीं करना होता। सपोज अभी तो हमने उसका डार्ट फाइल का नाम लिख दिया, रीड कंट्रोलर ये
हाँ,
डार्ट
नहीं नहीं, लाइन
फाइल।
नंबर 27 पे है ना, कंट्रोलर गेट।
हाँ, इसमें मतलब मेथड का नाम का डिफाइन किया हुआ है। अच्छा,
मेथड का एक्चुअली
गेट
क्या है,
गेट
यहीं पे अब मैं आई एम गोना एक्सप्लेन अ बिट कि यहाँ पर इफ यू वांट यू कैन एक्चुअली तुम ये भी कर सकते हो, तुम इसे इस कंट्रोलर को एक सिंपल क्लास बनाते हो, उसका मेथड यहाँ पास कर देते, राइट? बट बिकॉज यू हैव क्रिएटेड अ कंट्रोलर, या वी हैव क्रिएटेड अ रिसोर्स कंट्रोलर हियर, ठीक है? सो